Alright, so I'm going to discuss the remaining questions now, right? Yeah, so the remaining questions that we couldn't do in the live class, right? So now in this question, okay, you would have noticed that it's not solely hydrocarbons, okay, alone, right? In the essays, right, you can notice the pattern that it has other lessons along with hydrocarbons, right? So that's the whole way, like how they usually give for the exams, right? Except I think even there's like one full complete question in 2017 that we did, right? Although it's not a full complete, okay, it's just a small part, only A part has hydrocarbons, but usually even A part has some other chapter mixed, okay, B part has some other chapter mixed in the essays, right? So that's a pattern you must see. So those questions I will neglect for now, right? Because hydrocarbons, and sometimes you have the next lesson after hydrocarbons, it will have biosphere at times. Biosphere you haven't studied, no, right? Biosphere you haven't still studied with Ms Azhar. So once she teaches you that, you can come back. I'm hoping that you would. You can come back and do the biosphere part only, right? It will make more sense, right? But I'll just tell you the answer for the second question because it's nothing hard. But I just tell you the answer and keep. But anyways, you can come back and look into that. Not just biosphere. Sometimes unit 15, sometimes it's unit 3, right? Unit 3 that you learned what chemistry, what was it? The grade 10 unit 3, or sometimes unit 14, the rate of reaction, sometimes exothermic, endothermic, not sometimes, that comes most of the time, right? The exothermic, endothermic relations along with hydrocarbons somehow. Most of the chemistry lessons get combined with hydrocarbons because hydrocarbons is that much of an easy lesson. So always give importance when you're learning to hydrocarbons. You have to learn other lessons as well, right? But make your hydrocarbons first thorough, because at least then you can get that mark, no? So along with that, you can do the other this thing. It's like one of the easiest questions to gain marks, right? Okay, right. So let's go. Now the second question, I already did this for Nuha, but this is for Hafsa, right? So let me go for the second question. Right. So in this, right, they say that the natural rubber is a polymer. Okay, what is natural rubber? It's like they have told like a fact. We already know that, right? We already know that natural rubber, okay, is a polymer. It's not something new to us, but they have mentioned that in the question anyways. Okay, let's see what's next, right? So they're asking for the monomer which natural rubber is made up of. Now forget natural, the word natural value. Any rubber, whether it's vulcanized or natural, either way, any rubber, okay, rubber is the polymer. So what is the monomer? Monomer is isoprene. Okay, monomer is isoprene. Alright, okay, so what exactly is happening here? Let's see. Right, so now isoprene, okay, is the monomer. So how can you identify that? How can you identify that? Okay, this is the second question I am discussing, which is 2018 sixth essay. Okay, so they are saying natural rubber is the polymer, so isoprene is the monomer. Alright, so isoprene, the structure of it looks like this. Okay, it has a carbon-carbon single bond. Okay, this is an additional fact, not an additional fact, something you must know, right? If you know rubber is a polymer, isoprene is the monomer, that's the answer for the question number 1 of A part, right? So you have carbon-carbon single bond, and then you have a double bond CH2, double bond CH2, right? And single bond hydrogen and single bond CH3. So easy way I have told to remember is CH2, no, because it says 2, remember that there's a double bond connected. Since it says 2, there's a double bond connected. So people usually tend to get confused with how rubber looks like, but we know easily this is how it looks like. Okay, right, so let's move on. Okay, so the second question, they have told natural rubber is vulcanized by heating rubber with sulfur to a certain temperature. Okay, so let's see. Now they have told rubber, right? So earlier we were just talking about normal rubber. So now they are saying natural rubber itself, right? It is, what do you say? It is vulcanized. So what do you mean by vulcanization? You're simply adding sulfur, right? And you're heating it, right? You're going to heat the rubber. You're going to add it, and you're going to, you're going to heat the rubber with sulfur at a certain temperature, right? And then you're going to get what? You're going to obviously get vulcanized rubber, okay? You're obviously going to get vulcanized rubber. So now they are saying, okay, mention the structural change. Okay, mention the structural change that occurs in natural rubber during vulcanization. So they are not asking for any functional change or anything. They have particularly said structural change. So by structural change, what is understood here is this. Okay, take this fact, right? Structural means what you can see. So anything, okay, in the molecular diagram or anything, where you can see it, they are asking for a change where you can see something visibly, okay? That's happening during this process. So what is happening? Natural rubber, you should understand that it looks like this, right? Natural rubber, it looks like this. Basically, another term for that, you call it as linear polymer. Okay, natural rubber is a linear polymer, but once you add sulfur, the structural change that you can observe, okay, this linear polymer, this is like one chain. I have already explained. This is another chain, that's another chain. But once you add sulfur, it forms cross links. Okay, what does it form? It forms cross links. Okay, so between these two linear chains, you form cross links. It's connecting now. When it connect with each other, what will happen? The elasticity will reduce. Okay, here the elasticity was so high, that's why you can't really use a very high elastic rubber, right? So once you vulcanize it, the elasticity will reduce. And by how are you going to do that?